All right, for example 1, it says state the critical numbers along with reasons for the following function shown below. So when I see in the first part that it's changing from a positive slope to a negative slope, and it has this maximum point here where f prime of x is equal to 0, or when it's going from a negative slope to a positive slope and it's turning around here, where once again f prime of x is equal to 0, then I can say that both x equals a and x equals b are critical numbers. Therefore, f prime of a is equal to 0, and f prime of b is equal to 0. When I get to the second example here, I have this vertical asymptote at a. So it is going from having a positive slope to having a negative slope, but the original function can't exist at a, whereas at b, it's going from a negative slope to a positive slope, and it is continuous at this point, even though f prime of b is undefined. We can see that b is going to be a critical number. But x is equal to a is not in the domain. For example 2, it says consider the graph below and state everything you know about this graph that is relevant to our current topic of study. Well, I can see that I have a positive slope here. I have a positive slope here. I have the graph is decreasing here, and the graph is decreasing here. I have maximum points here and here. I have a local minimum point right here. And I can see that this is the absolute max, and that this is the absolute minimum of my graph. So let's put this information together. Firstly, f of x increases when x is an element of a to b or c to d, and decreases when x is an element of b to c or d to e. The second one, we have a absolute maximum when x is equal to d, and an absolute minimum when x is equal to a. We have a local maximum when x is equal to b or x is equal to d, and a local minimum when x is equal to c. And our critical numbers are going to occur when x is equal to b, c, or d. Fermat's theorem states that if f has a local maximum or local minimum at c, then either f of c is equal to 0 or f of c does not exist. Now, it's important to note that the opposite is not necessarily true. Just because f prime of c is equal to 0 or f prime of c does not exist, it doesn't necessarily mean that there is a local maximum or local minimum occurring at the point of c. One example of this is when we have that f of x is equal to x cubed. If I take f of x is equal to x cubed, then f prime of x is equal to 3x squared. If I replace x with 0, then f prime of 0 is going to equal 3 times 0 squared, which is still just equal to 0. So f prime of x is just 0. Now, that will be a critical number, but it doesn't, or appear to be a critical number, but it doesn't actually change from a positive slope to negative slope or a negative slope to positive slope at this point. It goes positive, has a slope of 0, and then becomes positive again, which means that there is no local min or local maximum at this point. So we know that 0 is a critical number that may be a local max or minimum, but we can't know that until we test it. So when it says determine the critical numbers of the following functions, all we're doing is we're going to take the derivative, f prime of x, for x cubed plus 6x squared plus 9x plus 2 is just 3x squared plus 12x plus 9. The critical number is when it's f prime of x is going to equal 0, so we replace that with 0. And then from there, I'm just going to factor. 3x squared plus 4x plus 3, 0 is equal to 3 and x plus 3 and x plus 1, which means that, therefore, the critical numbers in this case are x is equal to -3 or -1 based on the solutions to when f prime of x is equal to 0. If I'm doing it for f of x is equal to the absolute value of x, then remember, when we have the absolute value of x, we're going to have that cusp that exists at 0. So if f of x is equal to the absolute value of x, then that's going to equal -x when x is less than 0 is going to equal positive x when x is greater than or equal to 0, which means that based on that, f prime of x is going to equal the derivative of -x is -1. When x is less than 0, the derivative of x is just 1. When x is greater than 0, and those 2 points are going to meet at that -1 and +1, which means that f prime at 0 is undefined because it's a cusp or a corner. And the critical number is going to be where f prime of x is undefined at x is equal to 0. Note to self, the absolute maximum or absolute minimum value for a function will always occur at either a critical number or at an interval endpoint.